Alright, so now we're looking at the back side of our ticket to retake our test. We've got a few graph icons here. What we need to notice is that the graph is, what we're graphing does not have an equal sign. It has an inequality. So when there's an inequality, that means there will be shading and there will be a solid or dotted line. This one is already solved for y, so let's identify our slope and y-intercept. Slope is going to be a positive 2/3, so that'll be an uphill line. Y-intercept is -1. So we can start by putting our points on the graph, but we're not going to draw the line in. So let's just take care of our points. -1 on the y-axis, and then a slope of 2/3. So up 2, we run to the right to get that uphill line. Up 2 to the right 3. Then I'm just going to go back to my y-intercept and down. I don't know what I'm trying to say. Backtrack. I'm going to backtrack. That's what I'm trying to say. Or down track, you know. Oh, and I said we're not going to draw on our line. Let me get rid of that. Okay. So before we draw on the line, and you can see how easy it is to do, you just kind of get on the roll with graphing. We need to look at our inequality and make a couple of decisions. First, will this be a solid or dotted line? Well, if our inequality has this or equal to bar, so you can see the line right there, this is going to be a solid line. If it did not have that or equal to, it would just be a dotted line. Solid bar. I meant to say line. There we go. All right, now we are either going to shade above this line or below this line. And it depends on if y is greater than or less than the line. So this right here is a less than or equal to. And for the less than or equal to, we shade below the line. All right, so now I'm going to come to the line, or to the graph. We set a solid line, which I guess I did draw on before, but I did not know if it was going to be solid. All right, and then shading below. So shading below, like kind of straightforward on this one, but sometimes it's hard to tell what's above your graph and below your graph. So what I like to do is I tend to start at the y-intercept, and if I'm shading below, I'm going to draw an arrow straight down. And then I just go through the graph and I draw those arrows, and that's showing me which side of this line we are going to shade. So we're going to shade down here. So here I've got my shading. And this is what our graph of the inequality looks like. All right, so we can move on to number, I don't know, what number is it? Number 8. So the difference between number 7 and number 8 is a system of inequalities. So we actually have 2 inequalities to graph. So let's go through that. Well, you guys know me, this bottom one, I'm going to start with that one. That's just easier to do. It is already solved for y. So on this one, let's just take some notes on this line. The slope is going to be -1. The y-intercept is going to be -1. The inequality does not have an or equal to bar, so this is going to be a dotted line. And then that is a less than. Anytime it's less than, we are going to shade below. All right, so I'm going to get this on our graph. Let's see. -1 for the y-intercept. Slope is -1. This is a downhill line, which matches, you know, if it was positive or negative slope. And I'm going to go ahead and draw on the line. So we said dotted line, and I just drew it solid. Oh my gosh, am I even listening to myself? Let's see, let's get rid of that. This is a dotted line. So let's fill in a dotted line. There we go. And when we're shading below, I'm going to go to my y-intercept, draw arrow straight down. This is the side of the line that we're going to shade on. Now, I wait to do my shading till the end because I can see that we have another line to graph, and I'm just going to do the final shading in the end. So our other line that we're going to graph is this one. And this one is not solved for y. So we have a little bit of work to do. We have 6x minus 4y equals -8. First, let's get the x to the other side. We can do that with addition or subtraction. 6x minus 6x are opposites, so that equals 0. I'm going to carry down -4y equals... Now the -8 and the -6x are not like terms, but I'm going to write the -6x first because we like to have the x right after the equal sign. And then there's the -8. Then we're going to divide everything by -4. So that leaves us with y equals -6 divided by -4. It doesn't divide evenly, but we can reduce that to a positive 3/2 x. And then -8 divided by -4 is a positive 2. All right, so let's take some notes on this line. The slope is 3/2. It's positive, it'll be an uphill line. The y-intercept is positive 2. Oh, and did you guys see what I did? Man, look how easy it is to do this. So this inequality right here, when I came over here and started solving, I changed my inequality into an equal sign. We can't do that. That's not mathematically okay to do. I was just being careless. So now that you guys saw me be careless, now you will be less careless because you're going to look out for this. So I'm going to turn that first equal sign into a greater than or equal to. We subtracted 6x greater than or equal to. But then here's the thing, we just divided, if I go back to this step, we are dividing by a -4. Anytime we divide by a negative number with an inequality, you guys remember how this is going to change directions. So instead of a greater than or equal to, it's going to turn into a less than or equal to. Okay, we're back on track. We saved it. So our inequality, y is less than or equal to 3/2 x plus 2. Our slope is 3/2, our y-intercept is 2. So let's go ahead and get that on our graph. Y-intercept of positive 2, slope of 3/2, so up 3 over 2, up 3 over 2. And then we'll backtrack down 3 to left 2, down 3 to left 2. Oh, we did not take all of our notes. Over here, we said if it was a dotted line shading below, this line with the or equal to bar is solid. So we're going to draw it as solid line. And then because it's a less than or equal to, we're going to shade below. So let me draw in a solid line. We're going to shade below. So I'm going to go to my y-intercept and just put arrows down. This is the side of this line that we're going to shade. And so what we're looking for is the one region that would have solutions to both inequalities. So do we have a region that would get shaded from both lines? And we do. That's this one right here. Notice how my red arrows and blue arrows are both pointing into that. All right, we got one more on system of inequalities. It says, what system of inequalities is shown by the graph? Okay, so let's look at that downhill line first. This downhill line is solid. We are shading below it. The slope is So when we do slope, just try to find two exact points. And you can count your rise over run. So that's just down one to the right one. So our slope is -1, and our y-intercept is right here at +2. Our other line is a vertical line. This is a vertical line that crosses through the x-axis at +2. So a vertical line is going to have the inequality x and then 2. And we're going to put in, normally we would put an equal sign if it was just a vertical line, but this is an inequality. So because it's dotted, we can choose between greater than and less than. And in this case, the shading is on the left side of our graph. So this vertical line, this is the exception. This is the only line where you cannot shade above or below. You're actually shading to the right or to the left. As a reference, you can keep in mind how your x-axis works. Here's the origin. Numbers as we go this way, our numbers get bigger. As we go this way, our numbers get smaller. And we want all the, and we're shading this smaller side right here. So it's going to be all the x's that are less than 2. All right, now let's get our the inequality for the solid line. So we'll just do y equals mx plus b. So y, I'm going to leave a space for the inequality, but mx, so -1x plus 2. Now for the solid line, we did shade below, so it's going to be a less than or a less than or equal to. And it's a solid line, so that's our less than or equal to. Throw a little bracket off to the side, and this is our system of inequalities. All right, now we get to look at some word problems, everyone's favorite. All right, number 10, in a basketball game, the Rams make a total of 21 shots. Some of the shots are 2-point shots, while others are 3-point shots. The Rams score a total of 50 points. How many 2-point shots and 3-point shots did they make? So we are being asked to figure out two things. We are going to need two variables to represent these two things. And anytime you have to solve and figure out two things, you need two equations. So I'm just going to use x and y. I'm going to let x equal the 2-point shots. They want to know how many, so number of 2-point shots. So I'm going to let y equal the number of 3-point shots. All right, now we go to the problem and we try to write some equations. So and I'm going to reread it. In a basketball game, the Rams make a total of 21 shots. So that means they're shooting some of these and they're shooting some of these, and it totals to 21. So that equation is just going to be x, our number of 2-point shots, plus y, our number of 3-point shots, and that's going to equal 21 total shots that were made. All right, now it says some of the shots were 2 points, some were 3 points. They had a total of 50 points. So our 2-point shots has 2 points for each one, so 2 times x, all of those, plus our 3-point shots will use a 3, so 3 times y, all of the 3-point shots, will equal a total of 50 points. And now we're going to solve the system of equations. We could do substitution or elimination. I think it's set up very nicely for elimination. Maybe we'll eliminate the y's. To get those y's to be opposites, we're going to multiply the top equation by a -3. And then we'll rewrite our system over here. So we're going to have -3x minus 3y equals -42. And then I'm just going to carry over the bottom equation, 2x plus 3y equals 50. And now we're going to add our equations together. -3x plus 2x is a -1x. Our y's are opposites, so they add to 0. And then equals negative 42 plus 50 is a positive 8. So if we just keep solving, we're getting x equals 8. So x was our 2-point shots. So we know that they made 8 2-point shots. Now, how many 3-pointers did they make? Well, we got to take that 8 and plug it back in. We can plug it in for this x right here or this x, whichever one looks easier. I do think the top equation is a little more basic, probably easier for us to solve. So if we take, this work right here, x plus y equals 21, but now that we know that x is 8, we're going to say 8 plus y equals 21. Then we just subtract 8 from both sides, and we get 13. So they made 13 3-point shots. So because this is a word problem, I don't want to just throw my answer together as an ordered pair. Let's actually answer the question. How many 2-point and 3-point shots did they make? So they made, all right, x was the 2-point shots, and we said x was 8. So they made 8 2-point shots, and our y value was 13. 13 3-point shots. Okay, that's quite sloppy, but you guys have your audio on, so I know we're listening. All right, 2 more problems. Number 11. 2 groups of friends go to a baseball game. Each group plans to share the snacks shown. What is the price of 1 drink and 1 pretzel? So we're being asked to find 2 things, the price of 1 drink and the price of 1 pretzel. So let's use our variables to represent that. Maybe I'll just stick with the x and y. X can equal the price of 1 drink, and the y can equal the price of 1 pretzel. All right, so we're given some information in the picture here. First, it says 3 drinks and 2 pretzels cost $16. So x is our drink, so we can say 3x plus y is the price of a pretzel. And I'm just looking at this right here. We're getting 2 pretzels times the price, and that's going to equal $16. All right, our second equation is going to come from this, 5 drinks and 5 pretzels. So 5x plus 5y is going to equal 31.25. Okay, so solving the system, we could use substitution or elimination. These are both in standard form. We do not have an x equals or y equals, so elimination will just be the more efficient way to do this. When I look at this, why don't we eliminate, I don't know, the x's? We want those x's to be opposites. 3 and 5 can multiply into 15, so I'm going to multiply this top one by a 5. That's going to give us 15x plus 10y equals 80. Bottom equation, we need to, what do we say? We're eliminating the x's. So we want this 5x to multiply up into a negative 15x. So we're going to multiply this equation by negative 3. Negative 3 times 15x is negative 15x. Negative 3 times 5y is negative 15y. And negative 3 times 31.25 is, oops, negative 93.75. All right, now let's add our equations together. Our x's are opposites, those add up to 0. Then we have 10y plus a negative 15y is negative 5y equals 80 plus a negative 93.75 is negative 13.75. Then our last step, we divide both sides by 5, and we get 2y equals 2.75.
So what did we just figure out? Didn't we define our variables up here? We just found the y, and we can see that y is the price of a pretzel. So pretzels are $2.75. We'll put our final answer in a sentence. Now, to get the x, we're going to go back to one of the original equations over here. Let's plug in a y for this y or this y. Maybe I like this top equation better. I mean, it just looks a little easier, wouldn't you agree? So that top equation, we have 3x plus 2 times, I'm going to plug in the 2.75 equals 16. So we're going to multiply 2 times 2.75, and that's a 5.5. I'm going to carry down the 3x plus, and our equals 16. Now, two-step equation, let's subtract 5.5. 3x is equal to 10.5. And then when we divide both sides by 3, we get x equals 3.5. All right, so let's answer the question. The question was, what is the price of one drink and one pretzel? So we can say one drink, whoa, let me zoom in. One drink is, I already forgot. Our drink was our x's, right? So that was our 3.5. And one pretzel is 2.75. And we have answered the question. All right, last problem is over here somewhere, right? Oh, here we go. Ooh. All right, to fulfill a grant requirement, a school has to spend at least $600 on molecular sets for students to build models. Large kits cost $23 and small kits cost $12. Write an inequality that represents the number of each type of molecular set the school can buy. If the school buys 20 large sets and 10 small sets, does this meet the grant? Ooh, a typo. Mr. Dangler, do not catch my typo. The grant requirement, explain your reasoning. Okay, so we're talking two things, right? Large kits and small kits of these molecular kits to build models. So I'm going to let x equal number of small kits. Y will be the number of large kits. All right, so what do we know? They have to spend at least $600. Large kits cost $23 and small kits cost $12. So small kits are $12 times every kit. In addition to that, we're going to buy large kits, which cost $23 times every large kit. And it's very tempting to say that this is going to equal $600, that it equals $600 exactly. Now, that's not what they said. They said that we have to spend at least $600. So sometimes when money is raised in this example, like through a grant, you can only spend money on the thing that you raised money for. So this grant, in order to get the money, we had to agree, yes, we will spend at least $600 on these molecular sets. All right, so we don't want equal 600 because it's not exactly 600, it has to be at least. So what inequality would represent at least? So at least means that 600 is the least that it can be. So we're looking for a greater than or equal to $600. All right, follow-up question. If the school buys 20 large sets and 10 small sets, does this meet the grant requirement? Well, now that we have an inequality, we can just plug in those values for x and y and see if it's true. So, what'd they say? I just read it. If the school buys 20 large sets, so large sets are the y, so 23 times 20. Let me see. And they also want to buy 10 small sets. So 12 times 10, our small set. Is this greater than or equal to 600? That's what we're trying to figure out. All right, 12 times 10 is 120 plus 23 times 20 is 460. Is this greater than or equal to 600? 460 plus 120 is 580. Is that greater than or equal to 600? No, it's not. So, can the school buy 20 sets, 20 large sets, and 10 small sets? No. We just plugged in those numbers to the inequality we came up with, and we got a false statement. So that means that is not a solution. It would not be shaded if we were to graph these. All right, done. This was a long side, wow, but we made it.